Welcome, my dear student. Today we will talk about switching network and logic gates. As you know that there are three basic operations are used in Boolean algebra. The first one is logical addition, logical multiplication, and complement. These basic operations are called logical operations. When we consider logic 0 in terms of switch network, there are some words we will use in this way: false, off, low, open, no. When we consider the logic 1 in switching network, there are some words we will use in this way: it is true, on, high, closed, yes. So these are the words we will use in when we consider the switching network represented by logic 1 and logic 0. These are the words we will use in this way. Now what is our operation, student? Our operation represent here, it has either two values, if it is true or if it is false, represent by 1 or 0 in Boolean algebra. That is, if we added both of them, 0 plus 0 it is 0, 0 plus 1 is equals to 1, 1 plus 0 it is 1, and 1 plus 1 it is 1. And what is AND operation? It has either two values, true or false, 1 or 0. That is, AND operation represent here 0.0 equals to 0, 0.1 it is 0, 1.0 it is 0, and 1.1 it is 1. Now what is the complement? Complement of 0 is called 1, and the complement of 1 is equals to 0. Now what is switching circuits? We will define you what is switching circuit in switching network. It is very important terminology we will use in this way. If switch X is open, the value of X will be 0. If switch X is closed, then the value of X it will be 1. In terms of closed, it is 1. In terms of open, it is 0 in Boolean algebra. So when the switch is closed, the current will flow, and current will not flow if the switch is open. When the switch is closed, the current will flow. And the current will not flow, it means if the switch is open. So there are switch is open, then we draw a diagram. This diagram represent here switch is open, and when switch is closed, we form diagram. It means it is switch open, switch is closed. When we consider two switches are connected in series, so when we consider the switch X and switch Y, when we connect it with, it is in series form in this way. Or when we consider the two switches connected in parallel, it means when we draw a diagram, switch X and switch Y, if we draw a diagram in this form, so these switches are connected in parallel form, and these switches are connected in series form. In Boolean algebra, you know very well, student, there are some rules. In the previous lecture, we have discussed about the Boolean laws of algebra. A plus 0 is equals to 1, A plus 0 is equals to A. How can we show that this Boolean algebra, law of Boolean algebra, it in parallel and it is in series form? So A 0, A plus 0, or it is in series form, we write only A. But when the sign is multiplication, the parallel form represent here in this way. 1 we write here only. So A dot 1, it is in parallel form and the multiplication operation, and it is in series form. A we write only and we connect it in switching circuits. A plus A is equals to A. It is another law of Boolean algebra. It means it is in parallel form when the operation is addition. So it means A plus A, both are closed on both sides. It is in parallel form. But when we consider this, it is in write a circuit, it is in series form. So we write A only on the right hand side. Now the fourth law is if 0 plus A is equals to A, it means A plus A equals to 1. So it is in parallel form, and A plus A complement which is equals to 1, it means A and A complement, it is in parallel form, and the answer it is 1. So we write it is in this way, it is in series form. When we draw the complement A dot A complement, it means it is complement log with respect to multiplication which is equals to 0. So A dot A complement, it is in parallel form, and the answer it is 0. So we write in series form. Now commutative law with respect to addition, A plus B is equals to B plus A. It will show in parallel form only. So A plus B equivalent to B plus A. When we consider the first circuit is B, then add the second circuit. If we add circuit A with circuit B, they are equivalent. Now similarly, student, when we are applying the associative law, it means A connected with B and C, or which is equivalent to, then we connected first A and B, then we connected it is to C. So this is called associative law in terms of switching circuit. Now distributive law, A dot B plus C, which is equals to A dot B plus A dot C. So different will convert it into parallel form only. So A dot, it means it is multiplication. B and C both are connected with switching circuit. It is in addition form, and which is equivalent to A dot B means A dot B. This symbol represents here the multiplication. So we will applying in switching circuit. A dot C, it means A connected with C. It is a specific symbol we will use in this way. So this is called series. Now, and the law, associative law with respect to multiplication, A dot B of dot C, which is equals to A dot B dot C. This law is called associative law with respect to multiplication. It is in parallel form. It is in both cases they are equivalent because both are multiplication. So we write in this way, A dot B dot C and A dot B dot C, because B multiplying by A, so A applying this symbol, and B multiply by C first, so we are applying this symbol which is equal to B. So these are called switching network. Now after that, we will talk about the logic gates. What are the logic gates? It is an electronic device that operates one or more input signals to produce an output signal. It means if you have more than one input signals which produce only one output signals. So this type of gates are called digital circuits. Now what is OR gate? When we applying the symbol, it is OR gate. For OR gate, it means if the function, if it is an added form, A plus B, so there are two inputs, and f is equals to a plus b issue here, it is called output or OR gate. AND gate represent here, it is D type of symbol, and it is AND gate. So when both are productive from, these are input and both are multiplication, it means f is equals to a dot b is called output. These are called input. NOT gate. NOT gate only is friend. It is a single input and a single output. This bubble represent here the negation. It means this gate is called NOT gate. What is NOR gate? It means not OR gate. OR gate represent here a plus b, but not represent here f is equals to whole complement of a plus b. If we draw a diagram, it is in two ways. First, we consider OR gate, and both a and b are the input. It is called a plus b. Then we connect it with NOT gate, which is equals to f, which is the output. F is equals to the whole complement of a plus b. Or in another way, if we consider OR gate and a and b both are inputs, if we applying here a bubble, so it means it is NOR gate. We call it NOR gate in this way when we applying the bubble of OR gate. So f is equals to whole complement of a plus b. स्टूडेंट हम यहाँ दो तरीकों से NOR गेट को एक्सप्लेन कर सकते हैं. Now what is NAND gate? Not AND gate. It means the whole complement of a dot b. It is in a function, but when we draw a diagram, it is OR gate and AND gate. It is AND gate. A and B both are inputs. It means a dot b. Then we applying the AND gate. It means both are. It is in product form. But when we connect it with the NOT gate, which is equals to f is equals to a dot b whole negation of this input. And in another way, student, when we draw an AND gate, and if we are applying a bubble on the whole AND gate, so it means this is called NAND gate. When A and B both are input, when we are applying the bubble of the whole AND gate, so this is called NAND gate. So f is equals to a dot b whole complement. Now the next application about logic gate is student. Now it is exclusive or XOR gate. In another way, exclusive OR gate, it means XOR gate in another way. The formula of XOR gate, it is f is equals to a plus module b, or f is equals to, it means they are equivalent. F is equals to a complement of b plus a into b complement. This is called XOR gate. XOR gate represent here. First we draw a OR gate. We connect A and B both are inputs. It means it is f is equals to a plus b module. This line represent here this XOR gate. It means exclusive OR gate. So f is equals to a plus b module b, which is equals to a complement b plus a into b complement. What is XNOR gate? It means not exclusive OR gate. It is OR gate. When we applying this symbol represent here XOR gate. But when we applying the whole bubble, it is XNOR gate. It is XNOR gate. when it has two inputs A and B, which is equals to this out. What are the output? F is equals to A plus B, A plus module B of whole complement. This is called exclusive NOR gate, right? So which is equals to this. For example, if you have given function student, then A is equals to y is equals to A complement of dot D plus A dot D complement. These gates are interconnected gates. How can be established? So first we draw a NOT gate of A. It is NOT gate of A. Then we are applying this bubble, single input. But when we connected it into, according to dot, it means AND gate. Then A dot A complement and we connected with B. It means when we show here, it is B output. It is another output. It's connected with B. So it means A complement dot B. We represent here when both are connected with AND gate. So then we connected with OR gate. It means addition. So we are applying here. We draw an OR gate. Similarly, when we consider the right hand side of the second term, A, it means it is simple, A gate, dot represent here, A draw an AND gate, and B complement represent here. Then we connect B input and we draw a NOT gate for D, so it means this is called B complement, and B complement connected with AND gate, so it means B complement dot A. And both are connected with OR gate, so it means this is called output. Y is equals to A complement dot B plus sign represent here OR gate. So that's why we draw as it is. For example, student, another example about the AND gate. For example, if you have given function when the function depends on three variables, f of x, y, z, which is equals to x complement y complement z. It means all are multiplicative. So first we consider the x complement. It means if we draw the AND gate, how can we draw it? They write an application about gates. For example, if f of xy, which is equals to xy plus x complement y. And the next question about when we draw a gate, f of xyz, which is equals to x complement y complement z plus x complement y of z plus x complement x into y and z complement plus x, y, z, they are similar. So student, then we consider the question of 1 and draw logic gates in terms of two variables. So it means x and y both are multiplying. When we consider the input x and y, it means AND gate. X and Y, these are the input. Then we connected with an OR gate. It means when we draw a OR gate, what is X complement? It means negation of X complement. Negation of X, it means when we draw a NOT gate of X in this form, and the next variable, it is Y. When both are connected with AND gate, then it is X complement. It means the negation of X, and Y as it is, and both are connected with AND gate. It means X complement into Y, and then we connected OR gate. It means the component, the input output is equals to F of F is equals to XY plus X complement into Y. Similarly, for the next question, and draw a gate, logic gates. So it has three inputs, X and Y, X, Y, and Z, and both are multiplying together. First, we draw AND gate. It has three input. The first one is the complement of X. It means X complement, and Y complement. Both are multiplying, and the third input, it is Z. So X complement, Y complement, and Z, it is with AND gate. Similarly, for the next, X complement, it means X complement connected with AND gate. The second AND gate, because it has four values, so four AND gate we will draw one by one. Y, Z both are connected with this symbol. It means these are called input of the second AND gate. And the third one is X into Y complement, Z complement. Then we draw another AND gate. Y complement, it means NOT gate for Y and NOT gate for Z. So it means X into Y complement into Z complement, and the last one AND gate, it has three input. X, Y, Z. All are simple, and all are connected with this friend. OR gate. So it means the output, it is F is equals to X complement Y complement Z plus X complement Y and Z as it is plus X into Y complement Z complement, and the last one is all are added with OR gate. It means then we draw according to these symbols. So all are connected with OR gates. that's why I have completed my lecture. So I hope you will learn about switching network and logic gates. So thank you very much. Take care. God bless you. Allah Hafiz.